Alright, so this problem I actually got during an interview, and I think it's super useful to know how to do it. So if you guys ever had one of those older phones that had like letters on each digit, so for example, like the letter 2 would have like ABC, and the letter 3 would have like DEF, and you could like spell out words by hitting the numbers. What this question is asking you is it's going to give you a bunch of numbers as a string, and it's going to ask you how many different words or strings could you spell out given these numbers. So for example, let's say 2 maps to ABC and 3 maps to DEF. Well, you could have AD, AE, AF, BD, BE, BF, CD, CE, CF, and that would be what you return. You want to output all different types of combinations. The way you do this problem is you're going to want to construct a tree. So for the root node, this will actually be something like the empty string. And then what we'll do is for each mapping from like a letter, from a number to like 3 letters, we're going to create a node. And then when we encounter, let's say, the next number to letter mapping, we're going to make all of those children, all of those nodes, children of every single other node we've seen so far in the tree. So let's just, if you look at the example, maybe it's a little more concrete. So you start with 2, which maps to ABC, and the children of that, and then we go to A, and the children of that are DEF, and then you go to B, and the children of that are also DEF, and then you go to C, and the children of that are also DEF. So you can imagine if we had another number here, like let's say 4, and this map to like GHI, you would have GHI be a child, child of every other node still. So D would have a child that was GHI, E would have a GHI children, F would have a GHI children, etc. And what you're going to do is once you hit a leaf node, like once you've run out of like numbers to map, you're going to keep track of the path that it took to get to whatever leaf node you're at. Like let's say you're at G, you're going to go up G, D, A, and then the root is going to be an empty string, so we just ignore that. So GDA is one mapping, and then HDA is another mapping, and then IDA is another mapping, and so on in this form. So the 2 steps of this are build a tree, and once that tree is built, keep track of what your leaf nodes are and how you got them. So let's start coding this up. So the first thing we're going to do is we're going to have a solution set that we're going to append to, that we're going to keep adding to, and then let's have a function called recurse that takes rest of the word, and then we're also going to use a parameter to keep track of our path so far. So path so far. So like any recursive function, the first thing you're going to want to do is you're going to want to set a base case. So if not rest of word, right, if you've pretty much finished, you're going to add the path so far to your set, and then you're going to finish. You're going to terminate. Okay, so the next thing we're going to do is we're going to grab the first letter, as in, what's the first letter? Like, let's say we have a string like this, like 2, 3, 4. We're going to want to grab 2, and then we're going to partition off 3 and 4. So what that looks like is something like this. So rest of the word, get the first element, and then let's get the rest of the word right here. And then, of course, we want the mapping of a number to like 3 letters or 4 letters, whatever it is. So I saved all that information in a dictionary in the object. So we're going to have something called like letters equals self.d of first. And then this is kind of like where the recursive element comes in. You're going to say for letter and letters, what are we going to do? We're going to recurse on the rest of the word, but we are going to add different things to the path. So that's going to look like this. Cool. Okay, so this is honestly pretty much our function. This is all you really have to do. It's fairly straightforward. Wow, it looks like I have a lot of space there. Okay, so now we're going to call recurse on the original root node, which I think is called, I actually forgot what it's called. It's called digits. So let's go back down. We're going to call it on digits. We're going to start with the empty string, and let's see what, oh, of course. Recurse. Okay, so it looks like I'm basically just getting bogged down by small errors. Okay, there we go. So that's the right answer. So once again, all we really did is, although I did not use this tree data structure, is I built out this tree sort of, and while I'm walking down the tree, I'm keeping track of how I'm getting to each spot. And then when I hit the end, when I hit like a child node, I'm or an empty node or whatever, I'm terminating and I'm returning the path I've seen so far, which is basically a valid combination, to this set called combinations.